Hello and welcome to another episode of Anything Arduino. Today we are going to connect and set up the RC522 RFID module. For those of you who don't know what RFID is, it stands for Radio Frequency Identification, and it's a near-field wireless communication protocol technology that enables small and cheap tags like this, or this to store a little information. So each tag has a unique ID and a small memory in them and it doesn't need batteries of any kind, but combined with a reader like this one we're going to use today, the magic starts to happen. So you have a coil antenna here. I don't know if you can see it. So power is sent inductively to another coil in here, which then powers the chip on the tag, which then sends its unique ID and data back to the reader, and you can do something with this data. You usually get the tags in cards, as I said, or tags like these. These are the most common ones, if you don't count these tags that you find on almost all products today, which are used by the transportation industry. We also have outdoor stickers like this, or sew-on stickers for clothing and weatherproof of any kind. So places RFID is used widely today. In passage systems you get these instead of magnetic cards, like in hotels and stuff like that, or in human transportation as well. Also in transportation of goods and products you get these kinds of stickers almost on everything, letting the computer system know exactly where every product is. So I think you've seen a lot of these stickers around. As I said, they also have a small memory in them, around 1024 kilobytes usually, which can be both read and written to, of course, but this is a much slower process than just reading the unique ID. But this opens up for more security and more functionality of the tags. And also with most technologies and wireless technologies especially, there are a lot of different operating frequencies which all have their pros and cons. So today we're going to use the RC522, uses 13.56 megahertz, and it works with these two today. This works in a ultra high frequency and is not compatible with this one, but this one is also a much more expensive reader. So today we're going to build a simple passage system or electronic lock with this one, and show you how to read just the unique ID to get to confirm some to enter and some to stay out. And I'll also show you a few tips on how to connect the locking mechanisms. But let's start as we normally do and download a library. So doing a search on Google on RC522 Arduino library, and the first result here is the Miguel Balboa RFID on GitHub. So let's go there, and we're going to download this. While it downloads, we have some examples, stuff like that. Let's read the README file. Arduino library for MFRC522 and other RFID RC522 based modules. Read and write different types of radio frequency identification cards on your Arduino. So we can write as well. That's good to know. And here is the pin layout. That is good for later when we are going to connect it. Okay, so we have downloaded the RFID library. As usual, we are going to go into our documents, Arduino, libraries, and we put it here like that. And we also need to remove the dash master, so just RFID. There. Let's open our IDE. Okay, so in our Arduino IDE, we should in our examples have RFID and some example files here. So dump info, fix brick UID. Well, you can fix bricked UIDs. Interesting. MIFARE classic value block, read and write, RFID default keys. So let's build the circuit and see what we can do with these. So let's begin. We have 3.3 volts, which is quite important that we take the correct voltage there. And we should have a ground somewhere. And then we have the MOSI and MISO, the SPI or the SDA and the SCK. So let's see. If we check the pin diagram here, reset to pin 9, the Uno. SDA to pin 10. MOSI to pin 11. MOSI, that's that one. And then MISO to pin 12. And finally SCK to pin 13. And SCK there. Now which one haven't we connected? RQ. And there is no reference to that. So here's our circuit. Now let's load up a sketch in our Arduino and see what this one can do. Okay, so let's open one of the examples. Should have a, let's do the dump info. Example sketch showing how to read data from a PICC, that is a RFID tagger card. Yeah. So let's use this one. Great. Let's see what happens. open up the serial monitor. Oh wow, that was a lot of information in this one simple plastic card. Let's do that again. Let's see what happened. Yeah, so let's see what we get out here. We do get the UID just by touching really quick like that. We get the UID. However, if we keep it, holding it for quite some time, there is quite a lot of information that is also displayed. Lots of zeros though. I'm guessing this can be changed. And the final row, 25 BCEFB0. Yeah, so that's the card UID in the end as well. Okay, this one. Oh yeah. So once again, need to hold it for all the information to come. But for what I want to do, I only need this one UID there. So by just using the UID, we can make a really fast application. Okay, so I've gone through the code and I have taken out the bare minimum to create this lock that we are going to do. So you have to include the SPI.h and the MFRC522.h, and you have to define the reset and the SS pins. Then we have to initiate the MFRC522 like this, and then these I have added for when we read, instead of writing the RFID to directly just dumping it out to serial, we are saving it as a string. And then we have, these are the strings, or the ID, unique ID of the cards that are okay to open our door. So if you want more, you can just add more of these lines. Just OK, RFID 3, etc, etc. So as many as you like. Because I don't have a lock, physical lock that we're going to try this on, and that your lock can look in many different ways, I've just put a LED on pin 7 that will light up when we have an OK RFID, and it will not light up when we have a not OK. So, and then we do the initialize. I kept the serial, and then we begin the SPI. We initialize the MFRC522, and we set the pin mode to lock to output because it's just a LED that's going to light up. We kept the void dump. We kept the dump byte array function because. But we changed it a bit. So instead of dumping out the serial, we fill the read RFID with a string, which is a string, and we fill it with the buffer of the unique ID. We also created a function for open lock. This is so you can do a lot of stuff in here. If you have a servo that you want to spin and wait a bit and then spin back, or if you have a solenoid or relay that you want to open a specific time and then lock it again. So in this case, we just light up the LED for 2 seconds, and then we and then we turn it off again. In the loop, we keep these lines, we look for new cards, and if there is a card, we select the card. And we do the byte dump byte array. We do this function here with the unique ID. Then I do print the red RFID just for debugging purposes and to show you right now. And then we have an if statement. If read RFID equals OK RFID1, then OK, then we run the open lock. It's okay to open the door. And if read RFID equals 2, etc., etc., and then you just copy this. If you want more tags to be able to open your door, you just copy this one along with OK RFID 345, etc. Or else it's not okay and we do nothing. So if we upload this to our Arduino, it will look like this. So first we try it with a non-OK key, and it just keeps on writing 84BA6A1A, which is a not OK number. Then we take our card that is OK, and we just flip it, and it turns on the LED for 2 seconds and not anymore, and then it turns it off. So yeah, a very simple locking mechanism using RFID. Okay, so I've made a few additions to the code to better show you what you can that you really can use this for locks. So I have two kinds here. I have a solenoid here connected via a relay, and in the code it is we still use, whoops, sorry about that, we still use the lock on pin 7, and it's just a digital write, digital write high and then low, just like before. Nothing different there. But then we also added the include servo, so we can use a servo. So we have a servo connected to pin 2, as you see here, attach pin 2. And in the open lock loop function, except for the digital write, we also have a my server write, position closed, and then wait for 2000 seconds, and then position open. And I realized that I placed these wrong because it's correct. No, it's wrong. Anyway, so you just have two positions, 0 and 180 there. So when I take my card and touch, first it does this, waits 2 seconds and closes it again, and then it opens this one. So once again, and this is the reason I have a solenoid connected to the relay, is because this one requires 12 volts first of all, and it takes a lot of power to get it to function. It's quite strong. So either you use it as it is, locked like this, and when you open it you can open the door, or you use it the other way and attach it to some other mechanism. Same thing here. Either you connect this to something sliding like this that you pull by rotation, or you put it on top of a locking cylinder that you can actually pull with, maybe not this small one, but a bigger servo. So just hope I made it a little bit more clear. And with this, I hope you have gotten some inspiration to do something interesting and useful using the RC522 RFID module, and maybe open a door or something, maybe a little secret passageway in your house with RFID. Remember that it's not completely safe, because anyone with one of these in their pocket can go past you on the street and scan your code and then probably copy it. If you go through Miguel Balboa's library, you will find a lot of things you can do except this really simple project we did here. So hope you had fun, and see you next time. Bye. Subscribe. Always forget that. Please subscribe. Bye.